Welcome back, everyone. In this video, we're gonna start looking at some of the more confusing code that we're gonna be encountering in the coming videos once we go back to our SageMaker Jupyter Lab notebook. So over here, what you see is a sample. And this sample actually represents a single batch of data. And it has input IDs and an attention mask. Now, if you remember, a few videos back, we talked about input IDs and attention masks. So if we go back to this diagram, the input IDs are the token IDs. So for this simplified example, here we have a sentence that is made up of 3 tokens. So this is a very short sentence. It's like, I like dogs, okay? And corresponding to it is the attention mask, which we talked about. Here are the attention masks. And for our Mistral model, we're gonna have fixed sized chunk length of 2048. So that means in each chunk, we want 2048 tokens. And so that means we're gonna have an attention mask corresponding to that, which is also gonna have a length of 2048, and it's all gonna be filled with ones. Now, if you don't remember why it's filled with ones, please go back to, I think it was 2 videos back, where we talked about the attention mask. Essentially, it tells the model that, hey, pay attention to these tokens because it's not padding. In this example, the top one, you see that there's a bunch of zeros, and that's because the model doesn't have to pay attention to that input because it's padding. But for us, because we have a fixed size chunk length of 2048, or at least that's what we want to do, we're going to have the attention mask be the same length in terms of ones with our token IDs. Okay? So now, if we go back, think of it this way. This is the first sentence, and it's like a prompt that we looked at from our Dolly dataset, okay? Except it's a lot shorter so that, we can visualize it, because the reason why I wanted to do it separately in a Google Colab is because it's rather hard to visualize and see what's happening when we have so much data. So think of this first row as like the prompt that we use, the prompt template to create the instruction, the context, and the response. But this is just a shorter version of it. So we have the first prompt corresponding to it, the attention mask. Then we have a second example corresponding to it, the second attention mask. Third example corresponding to it, the third attention mask. Okay, so I hope that makes sense. And now what we want to do, our end goal is to essentially take all of the input IDs and take all the attention masks and flatten them out into a single array. Now, why do we want to do that? Well, because we want to chop it up into uniform chunk length, each equal to 2048. In this example, obviously, we don't even have 2048 in all the examples or all the sentences combined. But what we want to do is, for example, for the input IDs, it looks like this. And this is our goal, okay? We want to flatten it out, because once we flatten it out, then we can chop it up into the chunk sizes that we desire. And when we go back to fine tuning, that chunk size is going to be 2048. In this example, we could chop it up, for example, here. So we have 3, then here. So we have 3 again, and here. So this way we've chopped it up and each one would have 3, as you can see. And in our big example that we're working on, we just want to chop it up into length of 2048. But essentially our end goal is right now to flatten the input IDs array and also flatten the attention masks. So this is the first step. Now, this line of code could be a bit intimidating. So let's just walk through it step by step. So whenever we have something like this, we always go for this part first. For k in sample.keys. What is our sample? Well, our sample is a dictionary and it has 2 keys, input IDs and the attention mask. So on the first iteration, K is going to be equal to input IDs. So over here, this K is going to be equal to input IDs. So it's going to look something like, on the first iteration, input underscore IDs, and that is going to be equal to this ugly monstrosity. Now, what is this ugly thing over here? So let's delete this because we'll understand it in just a second. Well, over here, we first have to look at sample at K. Well, what is sample? It's this dictionary. And the K right now is equal to input IDs, right? Because we're looping over the sample. And for the first iteration, K is input IDs. So K is input IDs. And we access the input IDs from the sample. So this is what we access, okay? And keep in mind, this is not good for us, right? Actually, we access it till here. And this is not good for us because we want to flatten this input IDs array into one long array. So what we do? Well, we use the star unpacking, which we learned what it is. It essentially helps us unpack one level deep. So by applying this over here, we are left with this essentially. Input IDs is going to be equal to, right now, this is what we have. We have an array, we have 3 separate arrays, as you can see. So by doing the star unpacking on sample K, this is what we have now. And as you can see, this is bad because we have 3 separate arrays. So that's where we use the chain and the list operator. And chain actually takes multiple lists and links them together end to end into a single sequence. So what chain does is it takes all these separate arrays that we have here and combines them into a single sequence. However, chain is an iterator. So you need the list constructor here. You need the list to take that temporary iterator and build the actual permanent list data structure in memory that you can then use in the next steps. So essentially, we have to feed the iterator, which is chain, to the constructor, which is the list. Okay? And once we're done with this, we loop over, and then K is going to be equal to attention mask. And we do the same thing with the attention mask and also this nested array. Now, let's run this. And if you don't understand it now, I'm sure you will once we run this. As you can see, we first print out the sample, then we print out this double line, and then we print out, the concatenated examples. So at first, we have the input IDs in this nested array format, and the attention masks are also in this nested array format. Now, once we run it, as you can see, input IDs is going to be equal to, actually the concatenated example is going to be equal to a dictionary that has 2 keys, the input IDs and the attention mask. And as you can see, we have successfully combined it into one long single array for the input IDs and the same thing for the attention mask. Okay? And I know this code is ugly and could be intimidating, but I hope that, you understand it now and see what we're doing. Now let's scroll a bit down and actually let's see what happens. So over here, we have the same list. I just copied out this list. As you can see, it's a nested list or nested array. And then we did the same thing. We fed it to the chain iterator with the star unpacking, and we called the list on it. And as you can see, here we have our nice code. But what happens if we don't use the list? As you can see, we get an iterator at this memory, okay? So that's why we need the list, Okay, I just want to make sure that everyone understands why we need both the chain operator and the list operator. So just to recap, the chain iterator takes multiple lists and links them together end to end into a single sequence, but it only holds it in memory, in a temporary memory, and so you need to feed it in to the list constructor, which allows us it to be actually read in, and so we can actually access the elements. So I hope this made sense, and I will see you in the next video.